What is big data? This is Lasse Seppänen from Hammakhame University of Applied Sciences, Finland. Hello. Big data, by definition, means large amounts of data and analyzing that. There is no exact definition, but as you see, there are many words relating to big data. In those definitions of big data, it's collecting, preserving, sharing, finding and analyzing of very large, unorganized, continuously expanding data masses. Also, those definitions relate to the use of statistical analysis and IT systems. So, many definitions, but not one exact one. Quite often those definitions deal with the computers. Normal computers can't deal with the data in appropriate time. The data could be used in many places at the same time. Data could come from many sources, in many forms, and may change quickly. Often the data is automatically produced by some equipment, like IoT equipment, and it may be collected without any plan of use, just collected, and it may come in many structural forms, and the data may need to be processed even before analyzing it. Here are two definitions from Wikipedia. So as you see, even these definitions are not exactly the same. Pause the recording and see for yourself. Words starting with the letter V often relate to big data. So, words like volume, variety, velocity, and so forth. Please stop the recording again and read these by yourself. So, how much data is needed in order it to be big data? Many people think about different kinds of amounts, but in practice, if your computer can't handle the data, would it then be big data? So perhaps that is one answer. Also, the analyzing methods that are used to deal with big data, they can naturally be used for smaller amounts of data too. The data can be structural, so a clear and predetermined structure can be there, like in a relational database. That's the way a lot of data is. We know exactly where the data comes from, where it is located, and the data is always created with the same rules. The structure of the data can be loose. Example is internet page logs. For analysis, probably the data must be edited, or there can be no structure. So, for example, customer feedbacks and social media messages contain no structure of whatsoever. So, a programmer can not assume anything about their content and format. Also, we could be talking about useful and useless data. All data is in bits, zeros and ones. No longer we are talking about whether the data is analog or digital. Everything is digital, like statistics, business data, maps, pictures, videos, 3D models, data from heavy machinery in the factories, whatever. Some data is better for human eyes, some is better for a computer. A human eye likes photos. It's very easy for us to say what is in the photo. But they are not so easy for a computer to be analyzed. A relational database, however, is much easier for a computer, but for us it's pretty boring. The data in the ERP systems and other systems quite often is in relational database, so it's well organized and can be checked with the SQL select statements. The goals. So I have set to myself these two words, if and because. So if data collection, so the data is collected to see if it would be someday useful, and if not collected, so at least then it's not useful because we have lost it all. And then because collecting, the data is collected because some problems need to be solved, quality improved, more turnover produced, new products to be made, and so forth. Technically, collecting big data is possible because storage equipment have become very cheap. Clouds can be used to gather data quite nicely. Networks, both wired and wireless networks, are fast. Battery technology is also involved here because the technology can be located in portable equipment, and the size of the equipment is getting smaller, so the price is getting down. The speed of the equipment, the processors, is huge nowadays. And also IT systems have been developed, so analyzing and visualization of the data is getting better and better all the time. So the price is going down. The cost of sensors are coming down to almost nothing, much in the same way as computer chips. So the ability to monitor everything is becoming almost free. To connect that data or sensor point to the cloud is becoming a commodity. So this is said by Caterpillar. $5.5 million new equipment are added to internet every day. So watches, phone, thermostat, tractors, cars, and they all produce data. The data collections can be, for example, weather data, positioning data, traffic data, money transactions, computer game user data, data from sensors relating to machines, health, race cars like Formula Ones. And let's see about our lives. So around us there are many things collecting data. Let's see. Facebook and the friend recommendations. If we go to hospitals, there's a lot of data. Google Maps, having travel times and live traffic. Baseball, naturally all other sports too. There are lots of data gathered. Airlines, naturally, both about the traffic but also the airplanes themselves, how the airplanes work, so they gather a huge amount of data every second. Monetary things, banks, not only because of money but also identifying frauds. We have lots of consumer cards, and that data is very useful for shops. We could go to have a hamburger. They also gather a lot of data. And then we have all kinds of shops here mentioned. If you want to see films, there's Netflix, and like Facebook with friends recommendations, so also Netflix has the same thing about videos. And what we are looking more today about is Caterpillar. Let's see that soon. Examples. McKesson in the States has cut logistic costs within 5 years by $1 billion. It is a pharmaceutical company and it has a turnover of $97 billion, so they have cut one out of that. They have 60,000 active items with 30 distribution centers, 2 million products, 25,000 clients like hospitals, pharmacists and private doctors. And the costs were cut by analyzing the product quantities and where they are produced and the logistics. They had a clever software to do that, and it showed all extra costs, making everything visible. Quite nice. This is a picture of one show in Microsoft 2015 Convergence in Barcelona. And you can see Rockwell Automation here saving $300,000 every day by predictive maintenance. And here are also other data related operations. So Caterpillar functions for its equipment. So the machines are sending a lot of data all the time from various places of the machine. This is done over satellite connection. The data is then compared first to a standard machine. So how should a standard machine work? Then it's compared to the own history. So what has happened to this machine previously? And then there's a comparison to machines in the same kinds of environment, like Alaska, so doing operations in the oil fields, and then if the machines are used in Africa or South America, so naturally then there are different kinds of environments there. Then there's a deduction made when the maintenance is needed. Our business runs on the uptime of our customers. says the CEO of Caterpillar. So they want to do that with a low cost, and they want to win. They can have a sensor in the machine, and the sensor notices vibrations when the machine starts. And based on uptakes, which is the system for analyzing its algorithm, they know that within next 8 hours there could be a failure. And they can immediately send a technician with the spare parts to the machine. Not bad. So, history, data and presence side by side. The uptakes, the key to this kind of predictive maintenance is the history data and the present data working side by side with good algorithms. And the uptake system algorithm that is mentioned in the previous slide, so it was created using historical data of the past causes of downtime in the machines, and it works together with the machine's ability to communicate with one another and learn from each other's performance and downtime. Another example about tugboats and ships. There's an area where tugboat fuel pumps failed weekly. They used the IT systems and sensors for monitoring, and the data showed them when to change the pumps, saving them $35,000 a year. Well, not much, perhaps, but when the free time was better utilized, then the saving was $2 million per year. Role of shipping company realized that increasing hull cleanings of its vessels to 6 times every 2 years instead of once every 2 years. So the company was going to save almost $1 million. Very nice. Also, in this area there are excellence awards which 2015 were given to Financial Industry Regulator Authority and CERN, Momix Solutions, Black Arrow and Tidal. Presently it seems that the biggest data users are large corporations, because they have their own data and they have money, so that if they don't have skills, so they can use subcontractors. But startups, for startups this area creates a lot of possibilities if they have enough skills. Goals could be making better business, better quality, less failures and cuts based on preventive maintenance and planning, and new business possibilities and products. Bad data. Sometimes some of the data is corrupted or not relevant, and it's important to see when. And let's imagine a traffic speed controller. So the question is, when is the data bad from this equipment? Thinking that there are no errors in the equipment, So how does it work? There are these induction loops in the street, and the car passes over them, and so first this loop realizes car is coming, then the other one realizes the car is coming, and the timing difference can be used to analyze the speed. So what about bad data? When does this equipment produce bad data? Please pause the recording for thinking about these possibilities. The normal possibilities would be that there's a car overtaking other, so passing the loops on a different order than normally. Also, there could be a big load vehicle, so moving slowly from the other side, so carrying some industrial whatever, and occupying both of the lanes. Also, motorcycles could produce, or some other smaller vehicles like bicycles could produce some kind of disturbance here. Motorcycles, they can't be photographed with this system efficiently. A popular idea is to create a dashboard. So the data is shown in small sections of this dashboard. This dashboard is from the same Microsoft event, but the data here is artificial, so just from a demo database, nothing real. There are IT systems like Hadoop, Spark, R, different reporting systems like Power BI and ClickView, Jet Reports. And here we see Hadoop, and this is an example. So this is the whole system view, and down here is the Hadoop distributed file system. And it is possible to have many servers here, so the data is distributed automatically, and it's located in many places, so if there's a break in some of them, so it's still copied in many others. The data can be then accessed through these different modules. So script, so the kind of data that is in CSV files or other kinds of text related database, so it can be checked with pig module, and that's what we are going to see today. Also SQL files, NoSQLs, streams and so forth can be analyzed by Hadoop. And today we are going to see how Pig Latin language is used in programming, and then it commands the Hadoop to take in a data file, and then the data that is produced or analyzed by Hadoop is then dumped to the screen or stored to a file. And this is our original file. You can see that there's one line of titles, and then the next lines here contain a New York Stock Exchange data from 2001. And then there are these dates, stock prices opening, stock prices high and low, and closing, and then how many stocks have been changed and so forth. And this data is here not so nice for a human eye. but for a computer this is quite nice data. And this is the script that I made in order to see which was the biggest rise of price in a day, which day and which stock. And first line I command here to include this file into the system and stating that what are the different columns. So there's the exchange, symbol, date, opening as a float, high with a float, and so forth. And then I know that I'm interested only in the biggest or positive changes and getting to the biggest one, so I first filter out from this variable, as I call them. From that variable I filter out all negative changes, and then I dumped that to screen, and I noticed that there were some where the closing or opening prices were zeros, and we don't need them, so that's bad data. So I wanted to take those out. Naturally I could have done it easier, so close is bigger than 0 and or open is bigger than 0. So then from NUSA here to win, which is here, setting it here to win 1. Win 1 is then checked with that filter to win 2, and then I'm reorganizing the structure a bit so that this each of the lines in win 2 for each of the lines in win 2 we generate one line, so having only the symbol, date, close, open, and then close minus open, and giving that daily win name for that column. And then we order by the daily win column all the data, and then we dump it to the screen. And this is what we get. So still having the same kind of data, having the symbol for the stock, date, the prices, and here is the change. So $62 per day was the biggest change. Now twice with the same stock actually. Now this is not very user friendly for a human eye either, so it could be that it's a clever idea to use some visualization software in order to check this out in more detail. There are lots of different terms relating to data, and let's see from Wikipedia. So as you see from this, there are lots of different words, terms relating to data and data management. So big data is not the only term available. You could check this on your own a bit better. As there are lots of different terms relating to big data or data itself, so also there are other terms that are used. So like business intelligence and business analytics, open data, and so forth. And this is what I think. You may think different, and a lot of the people do, but a lot of people do think this way too. So this is one possible way to think. Let's see, here is the timeline, and this is where we are now. And if we think about big data, so we are collecting the data until now, so real-time data, whatever that is, temperature outside, or how did the caterpillar machine work until now, exactly now. So we have the history data until now, and business intelligence with a SQL database about how the sales have gone and so forth. So it's containing everything until now. Business analytics is something for predictions, how to look further from now. Also forecasts, weather forecasts, they are something that is for the future. But almost all are working for getting better business. A couple of words with open data. So the data must be public so that there's no privacy issues, no personal information or business secrets should be there. Technically it needs to be available in such formats that computers can read that data. It should be free, and the terms of reuse must be along with the data. And here is a link, so if you would like to go to see what kind of weather related stuff come from Finnish Meteorological Institute, so you should look at this video. Thank you.